My name is Deniz İlke Silistre. I'm an undergraduate student at Bilkent University Physics Department, and today I'm going to explain and demonstrate you our class project for Physics 211 course. We tried to build a Stirling engine out of the materials that we can find at home. Our initial thought was to build an engine and then work on the parts that we can improve its efficiency. But unfortunately, we couldn't manage to build a working one. Stirling engines are essentially uses the pressure difference in an airtight air chamber to move a power piston, and this power piston also connected to a displacer piston with a shaft, and the displacer piston works as a displacer of the air in the air chamber between a colder plate and closer to a hotter plate, and this continuous motion provides the pressure, continuous change in pressure in the air chamber. There are three main types of Stirling engines: alpha, beta, and gamma. The alpha type Stirling engine utilizes this separate rooms for the power piston and the air chamber and the displacer piston. We didn't try to build that one. We initially tried to build a beta type Stirling engine, which used this piston block, but it was hard to do since the displacer piston and the power piston would be in the same chamber, and it also required us to make a hole in the power piston that is frictionless and also airtight at the same time. And combination of two moving parts was led to huge problems, so we abandoned that style and tried to build a gamma type Stirling engine, which you can see here. That didn't quite work. We managed to overcome the friction problems as much as we can, and it works. It rotates pretty fine actually, but due to the problems in making it airtight, because it works in the principle of the expanding gases. When the gas expands, if it escapes the room, that means there is no push to the power piston. But it's really hard to make a piston and piston block both airtight and frictionless at the same time with the materials that we can find at home. But we did our best. Theoretically, our engine should work as follows. There is a heat source underneath, and okay, let me get it into a starting position to explain it step by step. As you can see, this arm is connected to the displacer piston, which is inside this air chamber. This displacer piston has a diameter slightly less than the air chamber itself, so it lets the air flow between these two plates, the top and bottom plate of the chamber. Since we put a heat source under the chamber, the hot plate would be the bottom plate, and the cold plate would be the top plate. And this is our shaft. The displacer piston is there's a 90-degree difference between the power piston's arm and the displacer piston's arms. If we put a heat source under it, the displacer piston will follow 90 degrees forward and it will rotate this way. Let us define this as the starting position. In this position, the displacer piston is on its most upper position, and the power piston is on at the middle way. So this position, the position of the displacer piston lets all the air be closer to the heating plate. So this provides a pressure higher than the atmospheric pressure in the air chamber, which pushes the power piston up like that, and this movement also pushes the displacer piston down at the same time, which moves the air away from the heating plate to the cooling plate. As the like that, this is now the displacer piston is at the lowermost position, which moves all the air to the colder plate, which leads to the air to cool and contract, which pushes the piston back to the its dominant position, the power piston. Actually, the pressure difference, the higher atmospheric pressure pushes the power piston in the lowermost position, which leads the displacer piston back up, moving the air from the cooler room to the hotter room, and this continuous movement of air between hot and cool rooms provides a continuous motion to the engine. We tried our best to make the chamber airtight on the and it is actually airtight on the sides, and it is also airtight on the mostly airtight on the power piston and power piston block. But unfortunately, we couldn't manage to make it as airtight as possible in the part that you can see here. I can come a little bit closer. Here, this part consists of a wire that is its outer diameter is 2.5 millimeters, and a tube that its inner diameter 2.5 millimeters. So that should be that is the as tight as we can get, but it's unfortunately leaks air, so our engine does not work due to those problems, the airtight problem.